this video we'll be talking about the queue. So what is basically a queue? A queue is a basic queue is a basic data structure which follows a basic principle, that is FIFO principle, that is first in first out, which means the element which is added in firstly in the queue will be the first one to be removed. Like, okay, in simple words, queue is like we stand in lines, right? We stand in the queues. So in data structures name is like queue. And okay, so for the basic example, like we have the real life examples for this. We have this. Okay, so this is okay. So this is how we stand in the queue. So this would be the first person, which and this would be the last person in the queue. So okay, so we take a basic example of how a queue is and how we are adding the elements and what is this FIFO principle and all that. So we have this. We all have gone to the theaters, and we have there. We will stand in the line to the ticket counter. So here this would be the first person to come, the first person to get the ticket, and this would be the last and this would be the last person to get the ticket. And the first person who came who get the ticket and then leave. So the first person who came in would be the first person who go out. So this is the basic principle, that is FIFO principle, first in first out principle. Okay, and this is the basic queue, like okay. So now we have the queue data structure. So we have two basic functions in the queue. We have like in queue and DQ. So okay, I'll write it here. We have two basic function in the queue, that is firstly we have in queue. What is this? Inserting element in the queue, inserting element in the queue. And then we have our second operation, which is DQ, deleting element from the queue. So we'll be deleting element from the queue, and that would be a DQ element. So okay, we have a basic principle here, that is FIFO principle. It would be first in first out principle, would be first in first out principle, which I've already explained. So for a queue, firstly it will be defining. Okay, so firstly second firstly we'll be making a class, that is queue, and that will be initializing, and that will be initializing a function, that will be self self. And then we have in that will be making an queue. So we have self dot items. So we have this defining is empty function, that is self is empty self. Then it will return. How would you get that it is empty or not? It will return length of self dot item, that is equal to 0. And then we have then we have in queue function, that is self dot items. Will be adding, will in queue function is to add is to add the elements in the queue. So we'll be adding the elements in the queue. Self dot items dot append, to add the element at the end we'll use append. That is, now we have defined the enqueue function, we'll be defining the dequeue function. If not self dot empty, then it will return self dot. If it is not, if not self dot is empty, sorry, self dot is empty, it will return to self dot items dot poke. And else like if the stack is empty, it will raise an error. It will raise index error. Will raise an index error that means what it will show that the queue is empty. Meaning front function. Okay, so front is a function which we want to see the front element without deleting the other element. So this is how we use front element. Would be self if not self dot is empty, it will return to self dot items zero. Like it means the index is zero. Index zero, that means the first element. So it is the like front. And again like if it's not empty, then it will again show this same, will raise the same error we have. That is the index of the queue is empty. It will show the same. Wait. Okay, then from here we have defining size only. Okay, we have size, and then we have self, wait, size. Will return the length of the queue, self dot items. And now we have defined all the functions. Now we'll directly go to the example how we'll be running these functions. Firstly, we'll be creating a queue. Queue is equal to wait, yeah. Firstly, we'll be creating a queue. I'll be creating my queue that is equal to queue which we have defined here. Now we'll be adding the elements in the queue. So we have my queue dot in queue 1. So like now I've added here 4 elements, 2, and then I have 3, and then I have 4. Now I've include the element, and now I'll print. Firstly, I want to see the queue size. The queue size, and then we have my queue dot size. Now it will return the size of my queue. Okay, size of my queue here. So here's I get the size. The size is 4. Okay, so my code is running. Okay, after that I want to go to the front element of this. So I'll get the front item. Here I'll call the front element that is my queue dot front. So I'll run this. So it will show me the front element is 1 as I've added it here. 1. Okay. So now we have done this. Now I want to delete threading while not my while not my queue dot is empty. If the queue is not empty, then will the queued item would be my queue dot my queue dot dq. So convince the dq, then it will print the same, that okay, my dq'd element is what would be it, that is my dq'd item. And if my stack is not empty, then it will print this. Otherwise, it will print that the queue is empty. Queue is empty. Now, queue is empty now. So, while using the while statement, it will keep on dequeuing keep on removing the elements, and this will get that, yeah, this was our queue size we get. This is the front element we have. Now we start dequeuing the element. The first element would be the first element removed would be the first element which is added, and that would be one. So this one be the first element, then second, then again third, and then fourth. Okay, so this is, and then at the end it's gonna print that the queue is empty now because all the elements we have deleted. So this was this was about the queues and the implementation of the queue. Thank you so much.